Hi everyone, it's Mrs. Martello. We're going to do section 3.3 and here we're using function notation. If you want to follow along, I'm in the textbook on page 122. So I wrote down a couple things here that maybe you should write down for your notes. If you want to pause the video and write this down, you can do that. So function notation is f of x. That's how you would say this, f of x. And really what this means is that it's a function of x. So f of x is really just another name for y. So it's just saying that y is a function of x, which means that if we input the x value, the y is the output, or the f of x is the output. Okay, so the x is still the input, our f of x is the output, but it's the same thing as y. Sometimes it's not always the letter f. Sometimes it could be g or h or any other variable. It could be m or j, but it always stands for a function. Okay, the first thing we're going to do is we're going to evaluate a function, and what that means is we're just going to take the number that they tell us and we're going to plug it in for x. Okay, first we're going to look at example 1 and then we'll try that monitoring progress question I had written down. So in example 1, our function is f of x equals negative 4x plus 7. We're going to evaluate it when x equals 2, then when x equals negative 2. So our first step is we're going to take 2 and we're going to plug it into our function. We're going to plug it in on the left for the x, and we're going to plug it in on the right for the x. So now instead of it being f of x, now it says f of 2 equals negative 4 times 2 plus 7. Now this left side, this f of 2, it's just a notation. You don't do anything with this f of 2. You keep it exactly how it is. Nothing is going to happen with it. We're going to simplify on the right side. So negative 4 times 2 is negative 8, plus 7 is negative 1. Now we're going to do it with negative 2. Let's plug negative 2 into the function. F of negative 2 equals negative 4 times negative 2 plus 7. Okay, you leave this f of negative 2 alone. Don't do anything with it. We're going to simplify on the right. Negative 4 times negative 2 is 8, plus 7 is 15. Okay, now we're going to do that monitoring progress 2 question here. Okay, we're going to evaluate g of x equals negative x minus 1 when x is negative 4, 0, and 3. All right, notice how this time it's a g, but it's still a function. Okay, we're going to input each one at a time. Let's start with negative 4. So we're going to have g of negative 4 equals, let's plug it in over here. This is the opposite of negative 4. So notice how the negative still stayed out in front, and then I plugged in negative 4 for x, and then minus 1. I'm not going to do anything with this left side. It just stays g of negative 4 equals, the opposite of negative 4 is positive 4 minus 1. So when I simplify here, g of negative 4 equals 3. That would be our first answer. Okay, let's do our next one. Now we're going to plug in 0. So we're going to have g of 0. Let's plug 0 in for the x on this side. The opposite of 0 minus 1, well, this would just be 0 minus 1. So g of 0 equals negative 1. Again, notice how nothing happens with that left side. It just stays in that notation g of 0. And what this means is that the function g, which is up here, when x is 0, the output is negative 1. Okay, let's do our last number. We're going to plug in 3. So we're going to have g of 3 equals the opposite of, let's plug in 3 over here, 3, and then minus 1. So g of 3 equals negative 3 minus 1. So that gives us g of 3 equals negative 4. And that would be our answer, just like that. Okay, we're going to keep going. We're going to skip example 2. We're going to go on to example 3. So now we're going to solve for the independent variable. And I'm going to write this down because this is something that I find people make a lot of mistakes on. Solve for the independent variable. Okay, when we do this, you're going to, first step, plug in the value for f of x or g of x or whatever that function notation is on the left side. Okay, it's going to replace that entire left side. And then your second step is you're just going to solve for x. So remember, the independent variable is x. We're going to solve for x here. Okay, let's take a look at example 3 and then we'll try one. So it says h of x equals 2/3 x minus 5. Find the value of x when h of x equals -7. So I want to take this -7 and I'm going to plug it in for h of x. And that's what's on the left side here. So all of this, the h and the parentheses and the x, this whole thing gets replaced with -7. And now this is just a regular two-step equation. We're going to solve for x. So we would add 5 to both sides, and then you multiply by the reciprocal of 2/3, which is 3/2 on both sides, and you get x equals -3. Okay, let's do another one like this. We're going to do monitoring progress number 5. Okay, this says g of x equals -1/2 x plus 3. And they're telling me that g of x equals -1. So I'm going to take this -1 and I'm going to plug it in for g of x into our function over here. So all of this is going to go away and it's being replaced with -1. So I'm going to have -1 equals -1/2 x plus 3. And now just solve for x. So we're going to minus 3 from both sides. -4 equals -1/2 x. Let's isolate x to get rid of this fraction. We're going to multiply by the reciprocal. So the reciprocal is -2/1, and that just cancels out this fraction. Let's multiply this side as well. -2/1 is the same thing as multiplying by -2. And then I get 8 equals x. And that would be our answer for this one. Okay, our last step is we're going to look at graphing our linear function. So to graph a linear function, we're going to make a t-table. So I'm going to write this down here. To graph, you're going to make a t-table. With your x's, you're going to go from -2 all the way to 2. And then you're going to plug in the x's to find the y's. Okay, then your last step is you're going to plot the points and draw the line. So because it is a linear function, you do want to connect it with a line so that it forms a linear graph. Okay, we're going to take a look at example 4 so that you can see how it's done. So we're going to graph f of x equals 2x plus 5. So notice how they set up this t-table here. So you would originally just set up your x's, and your x's would go from -2 to 2. Okay, after you do this, then you're going to find the y's. You're going to take each of these x's and you're going to plug them in one at a time into the equation. So I would plug in -2 up here. 2 times -2 is -4 plus 5 is 1. Then you plug in -1 times 2 is -2 plus 5 is 3. Then you plug in 0. 2 times 0 is 0 plus 5 is 5. What you should notice is now there's a pattern here. This should form a linear pattern. Do you see it's +2, +2, +2, +2? That should be the case because that's how linear functions act. Remember, they have a constant rate of change. Okay, once you have all your numbers in your table, you're going to plot the points. So this is the ordered pair, -2, 1. You plot that point on your graph. This is the ordered pair, -1, 3. You plot that on your graph. Then you plot all the points and you connect the points with a line just like this. Okay, we're going to do one of these together. We're going to do monitoring progress number 7. Okay, our equation or our function here is g of x equals negative x plus 4. Okay, it says we're gonna graph this linear function. So to do this, I'm gonna make a t-table. So I'm gonna set up my t-table here with my x's and y's. And for my x's, I wanna go from -2 to 2. So I'm just kind of creating my own t-table just like this. And then one at a time, I'm gonna take each x and plug it in. So let's plug in -2 into our function here. So then if I plug in -2, this would really be, when x is -2, it would be the opposite of -2 and then plus 4. So this would become +2 plus 4 is 6. Let's fill that in our table. Let's plug in -1. So when x equals -1, this would be the opposite of -1 plus 4. This would become +1 plus 4 is 5. Let's plug in 0. So when x equals 0, it would be the opposite of 0 plus 4. So this would just be 0 plus 4 would be 4. So now you should start recognizing the pattern. In the pattern, our y's are going -1, -1, and I'm just going to keep the pattern going. -1 would give us 3, and -1 would give us 2. So now we're ready to graph. I'm going to grab my piece of graph paper. And I'm going to plot these points on my coordinate plane. Let me go below it here. Okay, let me draw my coordinate plane. And I'm going to have x and y axes. You want to label your axes with x and y. 2, 3, 4, 5. I need to go up a little bit higher here. All right, let's start plotting our points. So our first point is -2, 6. So I'm going to go left 2, up 6. Plot your point. -1, 5. So I'm going to go left 1, up 5. 0, 4. So 0, up 4. 1, 3. And then 2, 2. Okay, and then once you plot all these points, then you're going to connect them with a line. So when you connect them with your line, you're going to have an arrow on both ends to show that this line is going to go on forever because it's a line, so it does continue on forever in both directions. So this should be your graph.